Hello, so in this video we're going to look at approximations of trigonometric function values. Now it's probably going to be good to have a calculator available to you. In my case I'm using the TI-84 and I just need to make sure that my mode is in degrees. So it's always best to make sure that the calculator is in the degree mode. Now, one easy way that you can determine whether or not it is in the right mode is just by doing sine of 90, and if it gives you anything else but 1, that means that it's not in radian mode, or not in degree mode. So yeah, so it should be in degree mode, and when you do sine of 90, it gives you 1. Similarly, like if you were to do like any other one that you happen to know, like cosine of 60 is 1/2, but if it doesn't give you 1/2, then that means that it's not in degree mode. So in this section, we're more or less just plugging in these values into the calculator. So you might feel like this is more or less just, yeah, plugging in everything. So let's say, for example, that we want to approximate the following. So we're just going to write tangent of 68 degrees and 43 minutes. And then we'll look also at cosine of 193.622 degrees. Now, these we're going to go ahead and go to the calculator. So, and we'll probably just need to, let's see, yeah, I guess we can do something like this, and then I'll just resize later. So, or how about this? Let's go ahead and say tangent. Okay, so we're just going to write 68, but then we're going to go to Secant apps, and we're going to type in the degree. And then we're going to put 43. So we'll put 43 minutes. So just type apps and then just do this one. Okay. Now here there's not much to do other than just say, okay, well, this is exactly what it gives me. So let's say that we just round 4 decimal places. Then that means that this is going to be 2.5771. Or 5671. Okay, so now if we look at similarly the next one, well, you have that you want to find cosine of 193.22. Now, 622. Now, if you put the symbol, it's going to do it for you, but if you don't, it's going to still do it. So that's because it's in degree mode. But we're just going to do it like this. So if we hit enter, well, it gives us this negative value, but that makes sense because 193 is in this third quadrant. So let's see, 0.9719. So we'll do negative 0.9719. Okay, so we have 19. Now, let's say that we were to do another example, but this one will be a little more complex. So let's say that you have secant of negative 287 degrees, and that's going to be part A. Now, let's see. Well, we'll also do cosecant. So cosecant of 35 degrees, or 35.8471 degrees. Now these are a little more challenging because of the fact that we're going to have to rewrite these, because if you look at the calculator, there is no secant, cosecant, and cotangent. But interestingly enough, we do have a method that we can do this. So one of the first steps that you're going to have to do is you'll have to say that secant of negative 287 degrees is equal to 1 divided by cosine of 287 degrees, and then, yeah, negative. So we're going to have to type it in symbolically like this. And then when we get the answer, we're just going to put that it's approximately whatever it tells us to be. So 1 divided by cosine of negative 287 degrees. Now consider this, negative 287, it's going in the reverse direction, and you know that each quadrant is 90 degrees, so negative 270 is coterminal to 90, so that means that if you go in a little extra, 17 degrees, it's going to place you in the first quadrant. That's really just a way of me saying that it's going to be positive. So 3.4203. So 3.4203. Now, similarly, if we go ahead and we say that part B says that you have cosecant of 35.8471 degrees, this is the same thing as 1 divided by sine of 35.8471 degrees. Okay, now we're going to do the same exact thing. We're going to go to our calculator and we're just going to type in that expression. I wonder if there's a way. So I can quit. Okay, so like let's say that we just do alpha y equals, and this is actually going to give us the rational expression, so we can actually just type it in like that. So let's see, we're going to do let's see, secant, cosecant, so 1 divided by sine, and then we're going to put 35.8471. Now, I didn't put the degrees back over here, so you should notice that it gave me exactly what I wanted. So if you want to put the degrees, more or less you can, but if it's degrees minutes, then that's where you'll have to put it no matter what. Otherwise it doesn't understand what you mean. So you type enter. So 1.7076. No, 7.6. Okay, so that's not too bad. Now consider this though. If you needed to find like a symbolic answer, so for example, like let's say that you had cotangent of, let's say 330 degrees. Well, for this one, you have to be careful because we know that, for example, that this is definitely 1 over tangent of 330 degrees. But then, you know, if you're going to go to the calculator and you'll say like 1 divided by tangent of 330 degrees, it's going to give you like an approximation. So 7321, so negative 1.7321 if we approximate like 4 decimal places, and we'll just change that to approximately. Okay, now, well, in the event that you needed like an exact value, remember that basically you could also just do where you draw the angle measure in the x and y plane, and 330 degrees, it looks something like this, where you have that the angle went around 330 degrees, so you have that that's the 330 degrees, but notice that it terminates in the fourth quadrant. So that means that relative to the x-axis, you would take 360 minus 330 degrees, and you would get that that's 30 degrees. So that means that the reference angle is 30 degrees. So what you would do next is that you would say, okay, well, that means that cotangent of 330 degrees is coterminal to, um, well, let's see. Okay, so yeah, so its coterminal angle is basically 330 because, yeah, it's between 0 and 360. But I meant to say the reference angle is 30 degrees. So we have cotangent of 30 degrees. However, it terminates in the fourth quadrant, so all students take calculus, so that means that it's going to be negative. Okay, well, in that case, that means that you could say negative 1 divided by tangent of 30 degrees. Now, again, the whole purpose of this is what if you needed the exact value? So if you needed the exact value, you would basically just say, well, I know that that's 1, that's root 3, and that's 2, and this is 30 degrees. So, accordingly, we have that this is going to be equal to negative 1 divided by, well, opposite over adjacent is 1 over root 3, so you have 1 over root 3, but that equals to negative root 3. So what that means then is that cotangent of 330 degrees is equal to negative root 3. Now, if you go back to the calculator though, and you type in like negative 1 divided by tangent of 30 degrees, you get the same exact thing. So in that regard, it's basically gonna just matter, like, whether you're looking for an approximation or not. But you can see that the calculator method is pretty straightforward, that you just plug it in and then that's it. Versus if you needed to show some work, then I would say that you would start by drawing the angle first, find the reference angle, then just reduce it as best as possible, so that way the expression is a lot more manageable and you can apply the trig triangles. And the fact that it terminates in the fourth quadrant, you knew that it was negative, and so on. So yeah, there's like a little bit of steps or downsides to looking for an exact value. Now, the other thing of which that we can look at, for example, is what if you had the following expression? Let's say that you had cosine of theta is equal to the square root of 3 over 2. But what we're going to say is that theta is somewhere between 0 and 90 degrees. Okay, now in this case, you would have to basically just say, well, because it's from 0 to 90, that means that it's in the first quadrant. The only issue that you'd end up having is that we actually don't know exactly the angle measure. So the only thing that we can be sure of is that we do have that, yeah, this is the angle, but we don't know what it is. So, okay. So we have 1 root 3 and 2, and this is 30 degrees, and this is 60 degrees. Now, based on the definition, we have that root 3 and 2 is the values that we were given. So that's adjacent, that's hypotenuse. But the value that corresponded to that was 30 degrees. So all that would mean is that you have that theta would have to be equal to 30 degrees. Now, if I use the calculator for this, that would have gave me the answer right away. Notice that you have these blue functions: sine inverse, cosine inverse, tangent inverse. So you go to secant, cosine, and you just type in the value that was given. So in this case, it was square root of 3 divided by 2, and then you just hit enter. So you get 30. So that 30 just means 30 degrees. So that was actually not too bad. Now, of course, if you wanted to find, for example, um, like say for example you have sine of theta equals to 1.71, and it's the same restrictions from 0 to 90, well, in that case, you would need to do theta is equal to sine inverse of 1.71, and then that's going to give you exactly what you need. So you just go to sine inverse 1.71 and see like how it gives you an error message because that was not possible. Let's say that we try another different one though. So like let's say that we have sine of theta equals to 0.7071. Okay, so that one's a little bit more manageable. So let's say that we go back and let's say that we try sine inverse of 0.7071, and then we just hit enter. So notice that this is giving me basically approximately 45 degrees. So what this means is that theta is approximately 45 degrees. So that would be okay in this regard. Now, let's go ahead and try some examples though. Okay, so me putting the number where you couldn't find it, that was just an example of that you just have to remember that there is a restriction. It's from -1 to 1 for sine and cosine. And then similarly, you have the same thing goes for like the other trig functions like cotangent, tangent, cosecant, secant. Okay. Okay, so these are some long digits, so just be sure that you type in all of it. And these are more or less not exactly arbitrary because these are kind of like exercises from your homework actually. So, I mean, every now and then you might get like a question where the number will come out nicely, like the one over here, the 45 degrees. So we said that the way of which that you can do this is by going and typing in secant, cosine, or secant sine, secant cosine, secant tangent, and so on. But it's going to be a bit more difficult when we get to like cosecant inverse, cotangent inverse, and so on, because those buttons are not built within here. So it's going to be a little interesting. Okay, so let's go to secant cosine inverse because that's the first one. And we're going to type in the number exactly as follows. Okay, so 92118,541. And then we're just going to hit enter. Now, let's go ahead and just round to the nearest degree. So that's going to be approximately 23 degrees. Okay, so we have that this one is going to be that theta is approximately 23 degrees. Now, notice that you have cotangent. Okay, so this is kind of weird. And I'm going to have to write it down over here. So you have that cotangent theta. Let's say that it's equal to x, for instance. Well, the thing that you do know is that tangent of theta would have to be equal to the reciprocal of this, because basically you know that the reciprocal function is 1 over tangent, so by that process you can just flip it as 1 over x. Now what this means is that basically that theta is equal to tangent inverse of 1 over x. So all that means is that to do this equation, we're going to have to solve it by taking 1 divided by this number and then taking the inverse of that. So tangent inverse of 1 divided by 1.4 4 446 474. Now we're just going to hit enter. Okay, so if we round to the nearest degree again, we get 35 degrees. So this will give us that this is approximately 35 degrees, and really I should put theta. That theta is approximately 35 degrees. Now, if we go ahead and we look at cosecant, sorry, cosecant of theta is equal to x. So by that process, we can similarly say that theta is equal to sine inverse of 1 over x. So in this case, like we have that that we can solve for cosecant by just taking 1 over sine, or cosine, sine inverse of 1 over the number. So we have secant sine, and our number is 1 divided by 1.3861147. And then we're just going to hit enter. Okay, so if we round to the nearest degree, basically that's just going to tell us it's approximately 46 degrees. So we can just say that this is going to be that theta is approximately 46 degrees. Okay, so one thing to kind of understand, like what exactly right now that you're doing with your approximations, is that you're just using that these functions, the sine inverse, we'll say x, the cosine inverse of x, and that the tangent inverse of x, all these functionalities is going to return you an x that's between 0 and 90 degrees. Meaning that right now we're just restricting to the first quadrant. However, if I was to say, for example, just kind of think ahead, like what if we didn't have that restriction? Then that's where things get a little messy. Because for instance, if I had wrote down the expression cosine of theta equals to 1/2, well, in that case, you might say, well, I definitely know that it's in the first quadrant, but I also know that it's in the fourth quadrant, sorry. So that means that you have something like this, but then you also have another one that goes like that. So then from there, that means that theta would actually end up being 60 degrees, but also 300 degrees. And that's if I was only going to restrict it to just a single rotation, meaning that if x was between 0 and 360. Now, similarly, if it was like plus or minus, then you'd have more. You'd have 120, and you'd also have 240. So that's just something to think about, because you know that if you did need like to include the whole rotation, you would have said, okay, secant cosine inverse of 1/2, and then you get 60. So then in that case, you just go back and you're like, okay, 60 right there, 60. But then you're like, oh, but it's also in the fourth quadrant. Well, then take 360 and minus 60, you get 300. So it's more or less like the same thing in a way, but it's adding on that you need to remember the four different quadrants and their signs respectively. So, this section was more or less just seeing that you can use those functionalities, that you can use the calculator to approximate the trigonometric functions or to obtain the theta value. But notice that you needed to do a little bit of work for the cosecant inverse, secant inverse. So I'm just going to kind of write those down right here. So secant inverse of x is the same thing as cosine inverse of 1 over x. Cosecant inverse of x is the same thing as sine inverse of 1 over x. And then tangent inverse of x is the same thing as, not tangent inverse, cotangent inverse. It's the same thing as tangent inverse of 1 over x. Now you'll have to be careful with these two because once we use the entire, well, let's say like this, once we start looking at the entire rotation from 0 to 360, then that's where this gets complicated because these have their own respective they have their own respective restrictions, so that's where these functions can be sort of complicated in that regard. But it's not too bad.